The speaker is off. Right, yeah, okay, cool. Yeah.
So,
do you see the
We're seeing the audio.
you still share your screen?
should be.
In here, and then entire screen. Okay, now you are. It's coming?
Yeah, there we go.
Oh. Turn this on.
Yeah, turn it on.
Okay, I hate to interrupt all these conversations because I know that they're really, really, really valuable. But what we wanted to do is maybe get started. We have a couple of people on Google Hangouts to be able to watch, and so we don't want to have them sitting there and waiting and wondering what's going on. So if you guys don't mind, we're going to get started. And I'm not going to bother you too long with my talk. We will have Dexter Fryer here. He will walk us through a lot of the work that has been done around Monasca, monitoring as a service. And then also we talk a little bit about the capabilities on using heat in connection with Monasca for auto-scaling. And we also have one of our engineers, Kanagaraj from India, on Hangouts, so he is as well there, and he will actually step in specifically on the heat part of that. So we'll bring him then in as needed. And I wish you guys a lot of fun and some good presentation from Dexter. And thanks.
Okay, are we good now? Is that okay for in the back? Yeah, good, okay. So we're here to talk about Monasca and heat, like Thomas said, and I'm kind of going to walk you through a little bit. We can go over Monasca, show you a little bit about the components. That way, there's quite a few moving parts in Monasca. So if I go through that, then at the end we'll get to the auto-scaling part where you can kind of see how that integrates with the auto-scaling, and it'll make a little more sense. Anybody heard of Monasca before? Everybody? Yeah, a few of you. Anybody using Monasca? No? Anybody know what Monasca means? No? All right. I'll get to that here in a second. A little bit about me. I'm a software engineer on the Monasca team. I've been with HP about 15 years, various roles, a lot on the server side. Did some work, big data work, and that transitioned over nicely to the cloud services work, which I joined about 4 years ago. So currently working on what we call when we ran a public cloud at scale, there's certain things in OpenStack that you just don't get. So if you want to be a provider, you have to implement those things. And those things we call foundation services on the back end, enablement type stuff. So I was on the metering and billing team for the majority of my time in cloud, and we were ingesting OpenStack data, processing it, moving it down to the billing provider. So a project you've probably known, Salometer, is what we'd used on that. So Monasca, monitoring at scale. That's where the name comes from. So after a lot of debate in the team, they came up with this name and worked out right. So how did we get here to Monasca? Public cloud, like I mentioned earlier, we started a public cloud and had to implement all of these things, all of these different services. So one of those was monitoring. So we had to learn that lesson implement that on our public cloud. So all of those lessons that we learned in public cloud, we brought forward, and that project is now called Monasca, and it's a scale-out architecture, fault tolerant, monitoring as a service solution. So, and it's got an OpenStack integration. We have just applied. If you go look at the Infra project, you can go and look, and you can see the application status. So we did do a review for that. It was either early this week. I think that was early this week that happened. So we're currently in the process of making it a top-level project, or making application to get a top-level project. Some of the uses for Monasca: application monitoring, service monitoring, monitoring things from the tenant level, and component monitoring. Really, anything you would want to monitor in an environment, you can instrument it with Monasca to collect those metrics. It's got a REST API, alarm engine, notification engine. We use Storm in the background to process the alarms. So that's what's also called, you'll hear, our threshold engine. That's what processes those. There's a kind of something you need to be careful with when alarm processing. So alarms are tricky. So you can get a lot of spurious alarms if you set thresholds too tight. So if you had something set at like 10 seconds and there was some network interruption, you might get alarms. So there's configuration in place. It's about 60 seconds on alarms, and whenever we walk through the example, you'll see we're going to actually go and make an alarm fire, and you'll get to see the notifications from that and everything else. Generally, we're an agent-based solution, so there is a Monasca agent, and it implements StatsD. So certain things come through. You can send either using an agent plugin, or you could use StatsD, or you could talk directly to the API. You could do that with your own code in application code, or you can do that we have a command line utility called Python or Monasca client, and it's a Python command line utility, so you can pass parameters to that and do the same kind of command. Monasca came from Datadog. It was a fork of Datadog, and so where we differ on StatsD, Datadog doesn't support dimensions, so our StatsD implementation supports dimensions, and I'll go over that a little bit later. It's some additional metadata on metric data. And then, so here's the stack we kind of went through on all the things that you could possibly monitor and from top to bottom. And it allows you to visualize what your environment looks like. So you're capturing all this metric data. You can also do analytics on that data as well. So if you wanted to, if there was some interesting kind of queries that you wanted to get off of maybe quality of service or something like that, you could do that as well. So this piece on the bottom left, it says events, future. So we currently have one, and I think the code's actually been pushed already. But so generally, Monasca, the first version was metrics only. The new components we're adding is events and logging, and actually there's several companies working on Monasca right now: HP, IBM, Fujitsu, Cisco, Rackspace. So there's several key players there. And Fujitsu actually is doing some work on implementing the Elk stack into Monasca. But the events work is ongoing and new and been pushed up. So this talk won't cover that. We're just going to cover the metrics and the heat auto-scaling piece. Our backend, we have two choices on our backend right now. Either InfluxDB, which is the open source version of the data store, or Vertica. Vertica is the HP commercial version that's available. So the Vertica one's community, so you can go download Vertica community and use it. Those are your two choices, and it's a config time option. So if you want to choose one or the other, you can do that at config time. And generally, this project, what we do on all of the config management, it's all Ansible scripts. So I'll show you where those repos are. And there's a nice little pattern to everything in Monasca, so that you can kind of, if you know what component you're talking about, you can guess the Git repo. So here's kind of some of the other stuff we mentioned. The benefits of monitoring as a service, SLAs, and reporting and things like that. These screens on the right, we're going to go through those. Those are actually the Horizon integration. And then we have a Grafana dashboard for your visualization. And we'll take a look at that as well. The architecture, this is the piece I was telling you. There's a lot of moving parts in Monasca. So if you look at it in the upper right, you have the agent, where that's pretty much the start of where all metrics come into the system. It would be for your application, something. And then we have a REST API, which is pretty common in the industry. Talks to the REST API. All this backend code, you never really have to deal with. I mean, if you're setting it up and providing a service, you're going to have to do that. But as a consumer or user on the front end, the top pieces are really the only thing you can see. And there's the Horizon dashboard over there, so we take a look at that later. And how that works is everything flows into our Kafka message queue, so it's a high-speed queue there. And then we've got the thing on the left is our config database, which is MySQL. Remember earlier I said we use our data store is going to be, we use Influx or Vertica, and that's generally for bulk data. What MySQL does is it's the low I/O load, so like alarms and notifications, things that are not really a high I/O load. That's where we put that. The threshold engine, that's Storm, and it's also called Thresh. Thresh is the code that we do for thresholding. This anomaly piece, that was some prototype work that was done in the past by Roland. He's the tech lead on Monasca. So he had demoed that, I think, in Paris is where he did that. And then the persister, that's responsible for persisting any of those metrics that come off of the queue. So that's kind of all these components will make a little more sense whenever we get into it and start looking at the code. Here's the posting sequence that we talked about, how it comes in through the API, message queue, notification engine, threshold engine, persister, and then the data store. There's a little bit of feedback, Thomas. So in the auto scale demo, we'll do that in the last part of this talk. We'll go over what the template looks like and the Monasca integrations that we've got working, and show you what that looks like. All these slides and the stuff that I'm using today, there's the QR code for it, so it'll bring up a GitHub location, and you can just git clone that, and you can get all this stuff here. One additional thing I'll show you before we get to the command line stuff. This is those are the commits, so you can see they're recent for Heat and Monasca. So that's the plugin for Heat and Monasca. So if you're interested in those, you can go take a look. Go clone that repo and take a look at that. So let's take a look at the Monasca piece real quick. Let me change this resolution so that you can see it a little better. Hopefully this display will stay on. Yeah, we're good. Where's that feedback coming from? Okay, so let's take a look here. So I've got a couple of demos that I can show you. One, I'm going to show you, we have a Monasca Vagrant environment. So if you go to github.com/stack4. So remember I mentioned earlier that we were applying for a top-level project. This is one thing that will change. Right now, the old model was you started in StackForge and then you graduated to OpenStack. The new model is you just start in OpenStack, and then when you meet the requirements to make a top-level project, they review them and you fix them, and then they would just move your code or authorize your code to be a top-level project. So this is one thing that's going to change. We're going to move this from StackForge to OpenStack because it's kind of a general-purpose thing now, according to the new rules, is that you just start in OpenStack. There's no really entrance criteria other than you're a legitimate OpenStack project or you have intentions to be OpenStack. So this is our Vagrant environment. So if you look at the, oh, by the way, all the docs which were on that other screen that you've seen were everything that should be in read the docs or which points to GitHub. So if it's like monasca-vagrant.readthedocs.org or monasca-agent, you know, they're all, once you see what the components look like, you can pretty much guess what they are. So there's a small setup for Vagrant. That's all listed here. Mac or Linux, whatever you want, it should work fine with the instructions that are here. So what I've done before this meeting was I went ahead and spun up a Vagrant environment on my notebook here. So it consists of, you get two VMs. One's a DevStack box and one's a box called Minimon. So I'm going to go ahead and close this out so you'll see what we're looking at. So I'll show you the boxes here. I want you, one of the other things I'm going to tell you is the Ansible roles. So the two pieces of Vagrant are when you do get clone Vagrant, you pull it down. Then the next step is you do Ansible Galaxy. We've got all of our roles in Galaxy. So you pull those roles from Galaxy and then Vagrant out. And so everything should come up and you should be able to do exactly what I'm showing you here. So let's see here. Okay, so there's the two boxes we talked about. Can you see this in the back? Is it okay? Yeah? Okay. I'll try to make this a little better. Okay, so we're going to log in. So these two boxes, all you do is you log in Vagrant SSH Minimon, Vagrant SSH DevStack. So what DevStack is running is it's running the Horizon pieces, the Keystone auth, all of that stuff. Minimon is running all of those components that you'd seen in the architecture graph. That's what it's running. So that's the difference between the two boxes. So if you made UI changes, you would need to log into the DevStack box and restart the web server, or things like that. So it should be all pre-configured and ready to use. So we're going to look at, so the Monasca command, the client that comes with it is just called Monasca. So if you look at the top, it gives you its standard conventions: create, delete, list, patch, show, update. So generally a list is give me a list of something, get an ID out of there, and then you do a show to see specifics about that. So we can do, if we do Monasca, I'll show you how this works. We'll just look at the notifications. We set up a default notification, email notification, which is what we're going to use in this demo to see how things work. So that shows you the notifications. And I'll show you the exact same thing in the Horizon console. So if you go to the Horizon console, which is, here's that IP address of the, so it creates two virtual boxes, and one is 192.168.10.5, the other one's 192.168.10.4, which is the Minimon one. So we'll log in as Minimon. And we will go to this monitoring tab here. And so the notifications that we just listed, they're right here. And you'll notice that the command line is more verbose than the UI. So there's certain things that you just can't do, like a metrics list. If you wanted to say, show me every metric that we have, you can't do that with the UI. You would have to go to the command line to look at that, or the API. So here's, if you go to this overview tab, so what we've done here, you see this Monasca health right here. We've actually implemented we're monitoring, we call it monitoring of monitoring. So we're monitoring Monasca with Monasca so that we can get we know what's going on. So if you look at this dashboard here, this is the Grafana dashboard I mentioned earlier, and you can create these and modify these and zoom in, zoom out, and do all kinds of interesting things. The dashboard here shows you all those components that I talked about: the API, the notification engine, the agent, the threshold engine, the persistor. All of those pieces are here. So that's kind of a good visual there to know what's going on with Monasca. And you can experiment, zoom in, zoom out, look at different times, things like that. These labels right here on the bottom, they're actually the metrics. So if we went and looked at the metrics in Monasca with Oh, put an S on there. Okay. So you'll see these are the metric names, and I'm going to arrow over and show you what this looks like. So the dimensions I mentioned earlier, those are key value pairs that go along with the metric data. So think of it like additional metadata that you can add to a metric. So if you had a metric that said host status, the metadata that you might want to attach to that is what host, like host name, and its key value pair, host name, localhost, something like that. So that's where the dimensions come into play, is that you can further define what that metric is, or add specific metadata so that you can understand what's there. The other piece we have is something called value meta, and that's metadata on the value. So, for example, let me find one. This CPU idle percent. The value that gets pushed in there, let's say it's 10. The value meta is like dimensions are for the metric name, but it allows you to put metadata on that value. So if it was 10, you might put like something like, it's a key value pair, so like value percent or something like that. That way you would know what the measurement is. Okay, so let's finish looking through the UI here, and this will make a little more sense. So the general dashboard on the overview, it shows you all the services that are currently being monitored by the plugins. So you can see the green or yellow or red status, whatever it is, whenever that changes whenever you get alarms. So a couple of important things here. There's a entity called an alarm definition, and then there's one called an alarm. Oftentimes there's a lot of confusion with that. The difference between an alarm definition and an alarm definition is essentially a template that says, here's what the criteria is, and there's typically a few of those. Alarms are the things that actually get created when events happen. Host goes down, creates an alarm. Host comes up, creates an alarm. So that's the difference there. So if you wanted to modify, you don't modify an alarm, you modify an alarm definition or create one. And then the alarms are a byproduct of that. So we'll go take a look at those here in a second. So there's your alarm definitions, alarms, notifications, and this is the horizon panel. So you can do certain things like create alarm definition here and things like that, or you can do it in the command line if you want to do it, or you can use Ansible, any number of ways that you can do that. So let's see here. So what we'll do here, just to keep this moving along. So I've got so I'm on the Minimon host right here from the Vagrant environment. So I'm just going to start a mail client. So it's set up to send it localhost, root at localhost. So we'll just modify an alarm, and I did this earlier, so we should be able to patch the alarm. Actually, let me show you what the alarm is we're going to patch first. Sure.
This Monasca, you can use it for monitoring each of the tenants and VMs and all you create, or is it mainly for the OpenStack infrastructure?
No, you can actually, it's not really, Solometer is really what does the OpenStack. We've got a Monasca project, which I don't think Fabio's here. Fabio works at Cisco down the street. He is actually heavily involved with that, and a couple of our engineers here. Monasca is a project that we kind of started internally prototyping to use Monasca as the back end. Solometer uses RabbitMQ, and there were some performance things that were issues running that at scale. So using Monasca as the back end for that, that's where all those metrics come from. Monasca is monitoring tenant-based things. We have a libvirt plugin and most of the other plugins that you need. There's very few that you really have to specially write, because we've got like a HTTP plugin so that you can do an endpoint check and things like that. Some of the newer ones, like I wrote a plugin for Influx, and I wrote one for Vertica. Well, Vertica how that one worked was I used IODBC and talked directly to Vertica, and Influx I used HTTP and called out to them and read a JSON struct that they returned and interpreted the data and sent it down. So there's different ways that you can do it. I mean, if you've got lower level integrations that you could do, I mean, I suppose you could write driver level integrations if you wanted to. But generally, it's for monitoring applications, services, tenant kind of stuff.
Yeah, can the ARM definition describe how you want to monitor the metric after the threshold has been exceeded?
Yes, that's this piece right here that we're looking at. This match by tells you how you can filter it based on whatever criteria. You see the expression right there. This line right here. Expression host alive status is greater than 0. This happens to be a host alive, but if you look at all the other ones, you can get examples of the different kind of arithmetic you can do on the metrics, so you can filter out how you best want to describe the alarm or the alarm definition. And then you can also filter it by the dimensions, which is this match by. And so you can get, so like on host alive status, for example, you could say, this one says match by host name, but you could have one that matched by other values, and you could just get multiple alarms for that occurrence, or you could get just one alarm, depending on how you want it to set it up. So this is the alarm definition. So right now you see the host alive status is greater than 0. So we're gonna change that alarm so that it just goes off and goes into alarm state, so that we can watch the notification. And I'm going to do that with the command line here, and I'm just going to patch the that exact alarm definition. We'll just do greater than or equal to 0, and then we'll take a look at that same alarm definition. So there's your greater than or equal to 0 expression. So it did patch it. So and remember earlier, whenever I said the thresholding engine was about 1 minute, so we should see in about 60 seconds we should see an alarm, and then we should see a notification. So what we can do is we can look at the alarms. Always get that backwards. So these are the current alarms, which is the same page in the horizon panel that we looked at, where everything's green. Well, that's the value you see over there where it says OK. Let's look at that. That's the state right there. So that will go to an alarm state. Let's see if we can get the hopefully fairly quick. So there it is. It's an alarm. So in the alarm state, and then it's got the alarm definition directive says it's an email notification. That's something else I forgot to mention, was we have actually several types of action notifications that we can do. We have a webhook, which is generally, it's a post webhook right now. Generally, you just put in the webhook in there, so when that alarm fires, then you want it to call some webhook, and that's how the heat integration is actually done. So whenever we set up, when we look through how heat is done, it's basically setting up a webhook that's pre-authorized, calls back in, and it'll create an instance for you for scale out. So we have email, we have webhook, and then another one we have is PagerDuty, and PagerDuty is essentially a webhook. The only real difference is we've done some additional work for error handling and retry code, but it's a webhook, but the code knows how to read how PagerDuty responds and respond accordingly.
Do you have any actions to do it? So once you get a notification, can you take actions against that?
Well, the notification actually it's actually producing an action. So one of them would be email. So it sent an email or a webhook. Whenever you put the webhook in there, it would call out to something else that would take action. So here's a prototype. So I prototyped doing some webhook enhancements earlier in the year, and what I did was I wrote some code to do. You could do delete, post, put, patch, whatever you wanted. And so one of the things I did was implement it to where it had 2 levels of notifications with the webhooks, and I would call out to GitHub whenever I got an alarm, and I would create a gist with whatever the alarm data was, and then I would take that GitHub link and post that into HipChat and say, operators, you need to take a look at this node because of this. So that was one of the cool things that I did with webhooks, was experiment with that so that you can do some things further. But it really doesn't, Monasca doesn't really, that's really out of its domain to do anything apart from tell somebody else about it.
Can we monitor the tenant databases?
You can really monitor. This is at the tenant level, so we're scoped at the tenant level right now. So we're actually, if we went and looked at the Keystone stuff, there's a Minimon. Let's take a look at that. Let's see the. So you'll see here we're the Minimon tenant right now. So everything that's running under here is under the Minimon tenant.
So this entire Monasca is running in one VM, or how do we run?
So yes and no. All of the Monasca components are running in one VM right here for this example. The other piece, the Keystone piece and the Horizon piece, is running in another VM, which is a DevStack Vagrant box, is what it is. So if you started DevStack on your own and configured it with the right credentials, then you can do the same thing. That's all it is. It's just a convenience thing. So here's the notification that we got. So this was an email notification because I patched that alarm. So I'm going to go ahead and patch that back when we're talking about this. And we should get another one. Put it back to how it was, and we should get an alarm okay whenever that happens. But essentially, here's your alarm data. It came in and it showed you, this is that alarm ID, if you'll remember. Remember we were looking at, generally you can say anything in this environment. If you've got an ID, then you can do something, some kind of show command on it. So, and that ID matches in the database. So if we logged into the MySQL database and we did show tables and looked in there, you would find the same ID. That's where all this data comes from. So generally you're looking for an ID. So if the data you have here, let's look at this one. This one says host status transition to the alarm state because we caused that. There's the dimension. So by this I know that the host name that we were monitoring was the DevStack host. So and the observer was Minimon, which is the one that we're currently on. So it was watching the DevStack node via SSH. And then that service is additional data that you can add on there to say what it was. So if we look at the other notification that we had, it's another host status alarm. So this one, a different ID, you see that it's for the Minimon host. So Minimon right now is configured to look at DevStack, and DevStack is configured to look at Minimon. So that's why we got an alarm, because we said greater than, and it went ahead and generated an alarm. So we got 2 alarms. So now if we look, we did a refresh here. Remember I patched the alarm. So we got a new status back. It says this is that alarm is in the OK status now. So those 2 alarms that we had, and if we look at the data down here, the ID matches. There's the DevStack one, and let's look at the next one. That one's in the OK status. There's the Minimon one. So we should be back. And if we would have, I should have shown you this, but whenever you look at the overview here, these would have went red. The little boxes would have went red. This Mon agent, if we have time, I've got a, which is in that, from that QR code. If you do a get pull from that, I've got an example there of a Vagrant file, and it'll spin up another VM on this system, and we can go and add a monitoring configuration to the host status plugin. So maybe we'll go ahead and walk through that. That way you can understand how the host status plugins work. So on Minimon, which is where we're running all of our Monasca components, if you look at, oh, by the way, all configuration, Etsy Monasca, all the config files are in there, all the log files, var log Monasca, and all the binaries opt Monasca. So it shouldn't be anything beyond that. The Horizon stuff, different story. You got to poke around for that.
Also, monitoring mode is
Say again.
how is that such taking place? When monitoring mode is actually using a session to go to the VM.
Yeah.
How does that happen?
The plugin's doing it because it's configured for access. The keys are all configured on the back end. Well, when we do Vagrant up, all of this environment is already pre-configured, so that stuff works. I'm actually going to show you. We're going to walk through an example. I'll show you the one bringing up a bare VM, and we're going to use ping instead, and just monitor it with ping. Because what happens is on intervals, the agent wakes up, goes through all the plugins, and does whatever config it says to do, and pushes those metrics up. So in Etsy Monasca, let's look at the agent and then conf.d. So there's also a way you can do custom plugins. Like if your business implements Monasca and you have private ones that are not going to be pushed into the mainline project, then you might want to do custom ones. And there's a custom conf.d directory that you could write your own and deploy them, and they would work from there. So let's look here. So there are YAML files here, and so this host alive is the one we're going to configure. So let's configure this YAML file. I did this earlier. I'm going to uncomment this. Then that way this hopefully will make a little more sense. So there's another, we're gonna set up a ping test from the same plugin. On the host name, it's called MonAgent, and we'll look at Etsy host. Earlier, I went ahead and put MonAgent in there, so I'm gonna call it 192.168.10.6. And so if we're looking at so I need to back up. So I'm going to show you what the git config looks like. That way you'll have some context. Okay, so we want to. Okay, so this is where you could clone this, which is what that QR code is. Okay, so we've got a Vagrant file. So we're just going to do Vagrant up is all we're going to do. It's just going to create a bare VM and install a couple of things. The Ansible stuff is here as well. See this MonAgent, MonAgent.yaml. So that's all it does. Very minimal. So we're going to do Vagrant up. And then when we change the config over here, for the host alive, I'm going to restart the agent. There's also a way, whenever you're configuring the agent, you don't have to edit the files. Most of the agent plugins, you can run them with setup, and there's parameters you can put on there, and it'll go and update the config for you. And that's all in the docs, too, if you're interested in that. So you can just run it with parameters, and it would update this. So we're going to do, I'll show you on all of the services are exactly like this. So you see, I'm restarting the agent. So if you wanted to restart the notification engine, it's dash notification, the persister dash persister. So all of it should have the similar pattern where it's Monasca something. So as long as you know which component you're talking about, then you should be able to guess at what you need to type there to restart a service or even run like the CLI. Everything is very consistent. Okay, so we restarted the agent, and what's going to happen here after this node comes up, the agent will start. We may get an unknown alarm on that host, because it's now going to start polling that every minute. So while that's working, we'll come back and look at that here in a minute. I'm going to go ahead and show you. There's another version of a demo we have, and it's a Docker. Anybody using Docker? Yeah, are you using it in production or experimenting? Production? No? Kind of figure you're in production with it. Okay, good deal. So that's an emerging technology, and it does some interesting things. So we've got a, if you go to the GitHub clone, again, you've got the, there's a Monasca Docker project, and let me go ahead and mention this while we're talking about it. So we had GitHub, StackForge, Monasca dash, all of those things. So if you go to github.com/StackForge and you type in Monasca here, it'll filter out all of the projects. And like I said earlier, this is going to be OpenStack later on. So this is all the Monasca related projects. So the things that are not really part of OpenStack, there's an HP Cloud-Mon, and this is in our wiki as well. If you look here, these are the other repos that we have. And these repos are things like Ansible scripts. Predominantly, that's what they are. So this is where the Docker demo's in here. Yeah, here's the Docker demo right here. So the Docker demo, the cool thing about it is, I'll show you what I did was I set up, I've got 2 instances running on the public cloud. So on the HP public cloud, hpcloud.com, I set up 2 instances earlier, which are right here, as a matter of fact. This is my account. I logged into HP Cloud, and here are the 2 instances that I set up. You can see there's their public addresses, 5050 or 4951. One's Monasca and one's DevStack. One of them I just spun up a DevStack. I literally did git clone, and that's where Heat's running. Git clone, I enabled Heat and brought up DevStack. The other one is Monasca, and what I did was I installed this is CoreOS. So we've got a CoreOS image, and if you know anything about CoreOS, it's bare bones. There's no utils or anything. So what I did was I just spun up I think it has curl with it. So I downloaded it with curl, and I pulled this image up. So this is the Monasca Docker image that I'm going to show you. So let's talk through that real quick. Actually, here we go. So that box came back up. Sorry for the context switching. Box came back up. We got an alarm for it. This was the one that we just enabled. There's your Mon agent was the name of it. And you'll notice that the alarm state says that it's in the alarm state. And then we got another one, said it went to the OK state. It probably went to alarm because the agent ran when Vagrant was bringing the box up, and then it went to OK state whenever the box came up. So, and that was just using ping. You were asking about earlier about SSH, so that's another example using ping. So if you want to poke around with all the plugins, there's a lot of them documented here. If you want to just look through the YAML files and kind of see how they work, that's a good place to start in the configuration. Look at the YAML files. So that box is up, so I'm probably not going to go any more on that. I'm going to try to transition over to the others so we can look at the Heat integration and maybe ask a few more questions. But in the demo, if you look at the test or the text file when you download it, it'll show you other steps. So it goes through setting up an agent on this blank VM. You could actually set up a Monasca agent and then have it start monitoring the other pieces. And so there's something there that you could probably get up and running on your own on a laptop, a minimal system, and you can experiment with it to see what it does. That's probably the best way to get started. Play with the alarms and things like that. So let's take a look at this environment here. So, pipe broken, that's not good. So here's what we're doing here. This is if you remember, we looked at the public cloud images. This is the DevStack one. And what I'm doing here is I'm running SSH tunnels. An easy thing, anybody else use SSH tunnels? Yeah, they're super convenient because you can get access to a UI for free. All you have to do is just forward that port through the SSH tunnel, and then you're good to go. So I'll show you what that looks like. So this is the DevStack box. So all those ports that are exposed, 5000's Keystone, and then you'll see this 8200. I mapped it to 8200 because I've got an 8100 on the Docker image so that we can get to similar things running on port 80. So that's why those numbers are so high, is just so that we don't have any overlap on this system. So we're going to log into that system there. And then we're in the DevStack environment, so we should be able to, let's see here. And this was just pulled like a day or two ago. And let's see if we can, so what I'm going to show you here is this box on the right. I'll kind of show you what we've got. I'm going to back all the way out. So this session right here, we're on my notebook right now. So I'm going to SSH to it, and you'll see it's got a different public address. I'm doing the same SSH tunnel here so that we can get access to the UI and look at it. So we're actually going to get to the Horizon UI, which this is, the one on the left is DevStack running inside HP Public Cloud, an OpenStack installation, and it's an instance inside there, and we're running DevStack on that. So it's kind of like OpenStack on OpenStack. So it's a little confusing, but it'll make a little more sense whenever we go through it. And the one on the right is an instance spun up in public cloud, and all we did was spun up a Core OS image and started Docker on the Monasca project. So we're on Core OS right now, and if you want to know, one of the things that I found easy to do is, you got a question? Say that one more time. We're not archiving right now. I mean, that would kind of be up to your policy as to how you wanted to do that. So another person that's working on the Monasca project is Time Warner, and they've got a production deployment. And so what they do is they have intervals where they purge data. So they have their business policy says our customers are only going to have data for however long, and so they would just purge the data from there. And you can do that. So the good thing about, one of the nice things about the way we've got the data stores separated, you can do bulk deletes, and influx are very easy because they just RM files is how they do that. So it's very efficient. If you ever want to know more about that, Paul Dix, he's one of I think he's the CEO of Influx. He did a talk on Influx and he describes some of that stuff, and it was a fairly recent presentation, and he kind of goes into the details about how that works and how efficient it is. So on the Core OS box, we're going to just shell into the Docker image that's running Monasca. And this is a way that you can do it. Let me show you first what. So if we do Docker ps-a, you'll see we have one container, and this is the Monasca demo. So if you follow the same instructions that's in the GitHub, then you'll get to the same place. So we're going to shell into it. So now we're actually on the Monasca container. And if you look here, you can see there's Monasca stuff running there. So we could do, if you wanted to do, look at the Monasca environment, if you want to do Monasca, let's see, notification list. Yeah, so you can see that you can get all the same data that we looked at earlier on my local Vagrant box. So I know I'm covering a lot here, several different environments, and it's probably confusing, but hopefully it'll make a little more sense if you're poking around with it on your own. Kind of pick, I would say pick one, and probably the Vagrant environment is the easiest because the public cloud one and trying to get that running is somewhat involved. So what we're going to do here, so remember earlier I talked about the webhooks and heat. So how heat works is we've got a template, and I'll show you that template here in a minute. What it exposes through the plugin, the Monasca integration, notifications, and it exposes the notifications through the plugin so that you can set those things up and be able to trigger on that and do interesting things like scale out, add an instance, or things like that. So what we're going to do here is we're going to look here we're going to do a heat command on the devstack box, and we're going to look for the resource list. And let me see if I can. I've got to have the right environment set here. So I'm gonna filter this out and show you Monasca. So normally, if you did heat, if you looked at the resource list, and these are resources that are exposed to heat, so that when you write your templates, these are available as things that you can. They're resources that you can add into your template that can do things. So you'll see the two things that are exposed from Monasca through the plugin is an alarm definition and a notification. So how that's important is what Heat would do when you set all this up, and you set up what's called a stack. And so in Heat, it's going to set this stack up for Monasca, and it's going to say, okay, here's an alarm definition, and here's the notification. And in this case, the notification, it's not an email notification. It could be, but in this case, it's a webhook. And so what that notification does is that webhook calls back out and spins up an instance. So whatever flavor you have defined, here's what the, let me show you what the template looks like. This is a fairly generic image, the one that it's using, but here's the different resources that we seen whenever we looked at the resource list in this command here, resource type list. And if you look at Heat, same commands up here. So they're similar kind of pattern, list, show, things like that. So this template here defines an auto scaling group, and I don't have access. I had an authentication problem on the Docker demo. Otherwise, I would show you exactly the workflow like we did the alarm, but it's really a matter of what happens is the same manner that we seen earlier where the host status changed and you got an alarm, that exact same thing happens whenever load gets high on, let's say you set it up for to run a web server, and you can see this template is defined where it says average utilization 50 times 1, so greater than 50%. So when the load goes up, that alarm would go off, and it would call out, the alarm would call that webhook, and it would call back into your infrastructure, spin up another instance. And Monasca alarms are different than Ceilometer. Ceilometer is continually alarming. Monasca, what it does is you get an alarm, and then something clears that. It goes below a threshold or something like that, and then it goes back into the OK state. So what would happen in this case is with this template in place and the webhook in place, whenever, if you had a single node and you were running I/O on it and it got above 50, it would call out, this template would execute, and a new instance would get created. And whenever the threshold got below 50, then that alarm would go back into an OK state. So there's all kinds of interesting things you can do with Heat and these templates, but that's primarily with Monasca. The two things that are exposed that we talked about earlier are the notification and the alarm definition. So the Heat demo, there was an auth problem with it, but generally if you're seeing, so I'm not going to run the specific part, but if you're seeing this resource list, the plugin is in place. If you don't see Monasca, then the environment's not set up right, or you didn't have the plugin. But now with the latest code I showed you earlier with Heat, that code should all be in place. And whenever you just do when you pull from DevStack, which this was, you'll get it. So you can do those integrations from there. So any questions on any of that so far? So the templates have provisions in there, so you can say, you can have thresholds in there. You can say, I want to go up by X number, and that's the max, or down by X number. And then I think there's also some intervals in there that you can say how soon that can happen, so that you don't get the same problem with like the alarm problem we would have, where things would start, you would start getting spurious activity, and which is not useful at all, counterproductive. So you definitely have to, you can manage that through the templates. So is this, yeah, go ahead. That's described in the Monasca docs. If you go look there, it'll show you what the syntax is. And in fact, if you do the Vagrant demo, let's take a look at that real quick. Let's see. Here's the coolest command I just learned about. This most command, anybody ever use that? I've never used it. I just learned about it, and it's the greatest command ever. I've always used less and more, and this is the greatest command ever. I mean, it's converted me over to, if you'll notice, you see how you can tab with it, and it doesn't wrap. It's so nice. So you can do search. I mean, it's got all kinds of power. It just made my week whenever I discovered this command. It's like, this is great. So here's the expressions that we were talking about right here. If you look in here, you can see the different kinds of expressions that are set up by default. So you can get an idea of what you can do with it. So there's some aggregate functions, average, and just kind of the common aggregate functions that you can do with that, and then just flat definitions that are greater than 90 and things like that. HTTP status greater than 0, it's going to be a 1 or a 0 on those, typically is what those are. So, okay, so let's see how we're doing on time. Are we okay on time? Yeah, 8 o'clock, we got plenty of time. So, is this interesting, good, bad? Yeah? Do you like going through the command line stuff better than the presentations? Is that helpful for you? Yeah, doing the demo, I like those too. Anything else that you want to see or questions about? No, what we were using in public cloud is, so early on when we started beta and all of that, we had different internal names for them, and they were highly specific to public cloud. So that's a, I guess you would say, another version of this. And so the things that we were doing there, the lessons that we learned, because it's kind of, when you're running a cloud at scale, it's kind of hard to just rip everything out and move with something new. So I'm sure one day that would be the case, but today it's the original, what we started with, and then all of those things, the lessons that we learned from all of it. It's the same people that are working on Monasca that started the monitoring. And I started with Monasca at the first of the year. I was with metering and billing before that, but all the same engineers, Monasca, that built public cloud and support it. So we have a libvirt plugin, so you can monitor that stuff with libvirt. But you're right, if you wanted to monitor, let's say you're an HP public cloud customer and you spin up an instance, you would have to go and elect to, I mean, obviously you would not do it by hand, you would do it with some config management, Puppet, Chef, Ansible, something like that. But you would have to elect to do that and have that infrastructure in place to collect those metrics.
So what kind of RBAC do you have in the hobby terms? How do you handle the
It's doing Keystone auth, V3 auth.
how fine-grained is the RBAC?
You mean what level can you scope to?
The only metrics which you want to use for billing or,
You're scoped to the tenant.
but at the same time, you've got the tenant metrics. So the admin wants to see the aggregated metrics.
So,
Should it be there?
yeah, well, there is a patch out there, and Time Warner actually, I think they were the one that pushed the patch. They had that exact request. They wanted to be scoped at the admin level so they could see everything. Obviously, as a tenant, you can only see what you own, but they wanted that. So there is a patch. I'm not sure if that patch made it to master yet, but it's out there and available, and that's in work.
Next step would be fix that for our offer on tenancy, so you can look at the metrics in the
Right.
in the aggregate.
Right. Well, because there's also a reseller use case, like in metering and billing. You know, we had a reseller use case, so yeah. Yeah, so you want to limit how deep you go on that. Anything else?
Some developers or something, for example, Nova or MeetUp, they have some warnings in their log, right?
Mhm.
So if you want to expose this kind of alarms, what can they do?
So that's another project that's, well, it's not another project, it's part of this project. So Fujitsu is actually actively working on the Elk Stack, which is the log stash and Kibana, Elasticsearch. They're working on code for Monasca to make that part of Monasca. And then we also have events. So those two things ought to solve that use case. Metrics alone really won't do that for you. You would have to have the logging and events so that you could monitor those logs and something to provide that level of detail.
So they use Elasticsearch.
Right. So yeah, if you're interested in that work, you can go look at I think that they created a separate repo, but they're actually, if you look under the reviews for Monasca, you can see the, let me pull that up while was there another question in the back?
You mentioned about the analytics on top of that. Just wondering what kind of analytics are they expensive?
Well, so I would phrase it this way: the analytics are, you have the capability to do that because the data is there and the data store is there, so that you could do that. You could expose that data, export it, whatever you wanted, or do any kind of analysis that you wanted, because it's time series data is what it is. It's all time series data. So if you want to do some kind of quality of service or something like that, or even if you wanted to, something more interesting is if you wanted to monitor your environment to, like, let's say you had some metrics on how long it took something to recover from a failover or something like that, you could take those metrics and you could decide, okay, I may be a little light on my provisioning and I need to add more instances, in which case would tie into heat, which is where heat would become important, where you could auto scale instead of doing those things as one-off tasks. You would obviously implement that in some kind of provisioning tool that would allow that to happen automatically. Okay.
Can Monasca be used to monitor security vulnerability?
Tell me, expand on that.
Well, if I have some kind of alerts, if something goes beyond the threshold, or for example, have some way to determine whether the system is in compliance on some security policy. Somebody changes something like that. It's no longer compliant. So what do I need in order to use this framework to monitor?
That sounds like more, you probably need events and logging with that, because what I would say is, so in public cloud, we had a thing, we dealt with fraud. So somebody would, whatever fraudulent accounts, and we would have to go discover that and disable those accounts and all that. That's probably a case to where you might have two solutions. One would be use the events and the logging to process known kind of things. And the other way you would do it is looking at your data store and finding out when things started arriving that were unexpected. Yeah, so you could do it in that way.
So, could you describe a little bit more about the event status of, for example, currently the DevStack had a external plugin interface. I just add this as an external plugin and
Well, Heat has the plugin. DevStack does not have the plugin. So when you enable Heat on DevStack, you do git pull on DevStack, and you edit the config, the local RC, you enable Heat, you get the plugin. It comes. It was just pushed. Before that, you had to do.
so basically Heat and the same. You just need a Heat
Right. And Conrad Garage is the right person to ask if you want to know developer level questions. I think he's Heat 4 now. His name was, let me show you his name. That way you can, he's the right guy to ask. He's actually on the Hangout. That's him right there in the middle, Conrad Garage. He's in India, so it's his time offset, but he's the right person to ask for that. Reach out to him, he works for HP, and he can answer those questions because he actually developed the Monasca and Heat integration. So if you've got deep technical questions on Monasca, it's the Monasca team. You can reach out IRC or the mail list. But questions about Heat and that interaction, he's the right person. Sure. Another question?
In the agent config, could users customize for application the number of ports open?
In the plugin, I suppose you could do that. You could do that. So if you're saying you wanted to write a plugin that would go and poll on some interval, and if it polled and found a port open, then it would send a metric. You could do that, and then you could have an alarm set up that said, if this number is ever greater than 0, like the host status, that's pretty much what you would do. You could do that. Yeah, do you have a specific use case in mind for that?
For example, the number of connections increased from 10 to 1,000, and you want to spin off another.
Yeah, but you do that differently. You would keep the metric of how many connections there are at all times. So you have a time series data, and then you set up alert or notification when it passes a threshold. You know, it's not that you're looking for a discrete number. I mean, because from an operational standpoint, you need to see the trends of things that are going on. It's not just, oh, I hit a number and I want to do something out of thin air.
Right. Is referring to just VM besides the ports. So you could be monitoring object like a VM or storage space, something like that. VM object. So what is this one? What you monitor will be different for different objects. So for some objects, it will be just
Yeah, but one of the things you got to remember, we're talking time. This is based around time series data, event data, and you're talking about a full monitoring system. So things that are events, time series data that you can track and do things about. This is what this is designed around. You know, that's what it's good for. If you start saying I have a whole lot of discrete things that are binary, they're on and off, yes, you can monitor that, but you're going to create a tremendous amount of overhead doing that.
not necessarily binary. I mean, everything but the storage. Let's say we reach like 1,000 VMs on point of view.
Right. So those things you're keeping a metric of how many. I mean, that's time series. You're tracking the metric of how many are running on the hypervisor, and then you're setting up alerts and notification when those metrics reach certain numbers or certain ranges, things like that. And that's standard time series data, which is what it's designed for.
So I think, yeah, I guess what he you said makes a lot of sense there is that in your use case, you might want to do something like so for example, heat and auto scaling, you would want to set up something that said, if that threshold, if I would be over provisioned on that node. So you would want to set a threshold, an alarm definition with a threshold for that, so that it would go off and you would do some provisioning elsewhere. But you could do it, what you were saying earlier is entirely possible. I will mention that you have to be careful with Monasca because I sort of think of it like the C programming language. It'll allow you to do anything you want to, which may not be helpful in the end. You could over monitor things and get too much data, and that would not be useful. So if you had 1,000 nodes and you wanted to monitor each of the 1,000 nodes from 1,000 nodes, that's not really useful. It's a lot of extra bulk data that you don't need, and it's overkill. It's in the big data world, kind of a replication factor of 3 is kind of the general rule of thumb. You know, if you put it to 7 or something higher, there's no real value in it. It's kind of a waste of resources, similar kind of pattern.
So we're seeing that Monasca is supposed to be fault tolerant.
So all of these components, there's no master, slave, active, passive type components in this environment. They're all scale out components. So everything, if you wanted to add n number of nodes, that configuration is possible. So Kafka, the API, all of those, they're independent. So I don't know that I would really say that's not necessarily a high availability component with respect to itself on one node, but if you had 2 nodes with the same age, then there's your redundancy right there. So all of the other components on the back end, Influx supports clustering, Kafka, you can scale that out and change the partitions how you like, and the persister as well. We run multiple of those. So all of those components are designed with the horizontal scale out architecture.
So you have so many instances of Monasca server.
Right here that we're looking at, it's a single node running everything. Yeah, because I'm doing it on my notebook. So yeah, no, production would never do that. Yeah, no, you would never do that. And then, generally 3 is like a good number to start out on really anything. But the heat auto scaling, if you dig into those templates a little more, you'll see how they have those thresholds. So that's where that would become important, is that you could scale up your infrastructure with heat in that manner as well. So heat is still an emerging technology. I don't know that there's a wide scale. It's sort of like Docker. It's a new cool thing, and everybody wants to see it work and get it working, but those patterns aren't widely recognized. So definitely pay attention to it, because the auto scaling thing is going to be important, and save time in the areas where we were managing this individually in the past. Anything else? Anybody got any? We've got probably 45 minutes. If anybody has a topic or news you want to share, anything like that, lightning talk, any projects, interesting projects? No? You got something? No?
Yeah, basically this is the iWiser project, and this iWiser just.
Can you get up to the microphone?
Here you go. Let me give you the mic, and you can.
The iWiser project.
The switch is on the bottom. Turn the switch on.
Turn it on the bottom.
There you go.
Yes. So iWiser project is just announced in Linux Foundation this Monday. So it's a project try to open up the kernel and the community collaboration, try to poke into the I/O side, networking, tracing, security, try to expose more, easy work for everybody, because currently a lot of people have different skills, different things.
Okay.
And from really initiated, and we're from some great company.
Okay.
We have this expanded BPF work and pushing to the Linux kernel. Basically, it is kind of like a kernel virtual machine. So you can have some user space code and execute in kernel, and you can tap into certain points in kernel to execute. For tracing, you can have to any kind of define the symbols, any kind of the function plus some offset, as long as that function is exposed by kernel. For networking, you can have to certain kind of the ingress or egress, like a traffic classifier, and even some people talking about the IP table, some kind of points to attach. So the thing is, you have this user space program, and then you just execute in kernel, and of course, user program cannot be arbitrary. There will be something, and to verify your program will be safe and cannot crash the kernel. But the idea is that you execute your program, this open opportunity for you try to really put into kernel, try to get more information, and sometimes change some kernel behavior, like dropping the packet, redirect the packet, modify the packet, or get some statistics about the disk, CPU, I/O memory. So welcome to basically this is a project. Welcome everybody try to collaborate. So make it a foundation for higher level applications like OpenStack. OpenStack will not directly use it, but some agent could use it. So
we might see a Monasca plugin for your project. Is that what I'm hearing?
Yeah.
Okay. 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 What else you got? Anybody got any other news? Topics? No? Good flow, too much demo? Is it confusing?
That was very nice actually.
Yeah? Okay. Well, I was afraid I was going to confuse you with the Docker, the public cloud, and all this other business, so you know it's a lot. Okay. What other kind of stuff do you want to see at future meetups? Suggestions?
Maybe something real world around the same analysis. I'm quite intrigued by the project.
Okay.
Definitely on an operational basis, I think now customers are thinking beyond just PaaS or IaaS.
What kind of
How do I
relationship
use
is
this thing once it gets deployed, right? It's really past those challenges of initial first phase deployment. It's a very interesting project. But I think something real world when you deployed it, what kind of queries made sense, what kind of visualizations made sense in a scale-out environment, what kind of challenges you had. That'd be very interesting.
So the operational side, okay. I was going to mention to you earlier, I forgot, I'm glad you reminded me. On Tuesdays, we have a public meeting, so anybody can attend. It's a WebEx meeting, we do video. Tuesdays, it's 8 a.m. your time, so if you want to get up, there's been a guy on there from Rackspace folding his laundry before. So if you want to attend, at least check it out once, see the faces. That was helpful for me. There's somebody from every company on there. That happens every Tuesday, and we just kind of talk about if there's any issues, blueprints that are going on, status of the project, or if you've got special requirements for the project that you need satisfied, or even new work that you're proposing. We do that on Tuesdays, so it's a good time. Yeah, Monasca project. And then if you needed something heat specific, you could do one of two things. Conjure, you could either see if he could join in on one of those meetings. Like if it was something Monasca related, send him a message and say, hey, Tuesday, can you get in on video call and include your topic and get rolling to put that on the agenda, or you can add it that morning. It's not really part of the agenda. So you can do that and say, hey, there's some issue or something that you're missing. We need to work through. Yeah. Yeah, they're all going let me put that back up and you can. Should have just selected. Here we go. That's the QR code for the GitHub site. So if you do that, then you can probably test it from back there earlier, so it ought to work. there's the wiki. So everything in this project is already set up for OpenStack. So that application I mentioned at the beginning of the talk, everything should be compliant. So if you go to the OpenStack menu, or OpenStack wiki, you should be able to navigate through Monasca. The mailing list, we've got a postman filter on the mailing list. So if you just want to watch Monasca mail. And then there's the two repos I mentioned, the StackForge one, and then the ancillary code, which is the HP Cloud Mon. There's our meetings. The IRC, admittedly, is not very active, but certainly if you want to get on there and ask questions and make it active, that'd be great. Predominantly, the mail list is used, and then there's the read.doc site. So look forward to seeing some maybe blueprints or anything like that. So anything else, Thomas? No?
No, I think if you guys don't have anything else, I think we'll call it a wrap up, unless someone else has anything else to talk, to share.
There may be some more pizza there. I don't know what else is left.
Any pizza left, feel free to take it.
Yeah.
Okay, then thanks everyone for coming.
Thanks.
I was thinking about sharing what happened in the operators meeting over the last couple of days, but I'm completely fried from it. It's just it's one of those my head's too full. I gotta leave now.
Oh, okay.
It was, that was a couple of hundred people in Palo Alto. Just